So that was part A. Here's a part B. Okay, let's do the same for. Okay, so let's do the same for cosec squared x. That is equal to 3 cot x minus 1. So cosec squared x equals 3 cot x minus 1, and it's the same question, so the range is 0 to 360. Okay, so the range is 0 to 360, so same problem, but this is part B. So once again, everyone, you have a power 2. Okay, so let me circulate that. So that means that we may need to use the Pythagorean identities once again. So chances are it could be a Pythagorean identities question. Yeah. So if we go back to the identities, so if we go back to the previous page, we need to change. So looking at our current equation, we look at the highest power term, which is cosec or cosec, and we need to change that to the least power term. So we need to change the cosec in cosec squared to a cot squared term. Yeah. So going back one page or a couple of pages, one of these identities enables us to do that. So we need to change that cosec squared term, okay, to a cot squared term. So if we go backwards again, so it's going to be one of these three. So the one for us is number 3. Okay, so 1 plus cot squared is cosec squared. Yeah. So let's revisit the steps. Okay, so step number 1, this is a side calculation. I'm going to be using the identity that we discussed, 1 plus cot squared x equals cosec squared x. So this is the one for us. Okay, and let's do that as a side calculation. But if I rearrange, I don't need to rearrange because I already have it in the form. So if I swap sides, cosec squared is 1 plus cot squared x. Okay, don't really need to swap it, but just to make sure that I have it in that form, so to speak. So cosec squared, will change that and replace that with 1 plus cot squared. Okay, so that is our step 1, our side calculation using the identity. In step 2, as from before, I'm going to replace cosec squared by 1 plus cot squared. So in step 2, let's do that. 1 plus cot squared x is equal to 3 cot x minus 1 on the right. And if I straightforwardly bring these two terms to one side, so if I bring these two terms to the left, I'm going to have cot squared x minus the 3 cot x, 1 plus 1, when you move the minus 1 to the left, is a 2, that is equal to 0. Okay, so that is my quadratic involving cot. Okay, now as before, so if we go back to the previous example in part A, okay, I also replaced, well, it was cos terms in the previous quadratic with t, so I let t equals cos x. Yeah, so in our case I'm going to do a similar step. I'm going to make that look like a quadratic. Well, it is a quadratic, but I'm going to make it so that it's easier for us to solve, so to speak. So I'm going to let t equals cot x. So in our case, let's let t equals cot x, and if I do that, I'm going to get t squared minus 3t plus 2 is equal to 0. Okay, so I have a quadratic. Okay, and if your factorization is well and good, you will be able to factorize that straight away. So if I were to factorize, the factors would be t minus 1 and t minus 2, that's equal to 0. Okay, now so from there on, So you've got two values of t, so either t minus 1 equals 0, that means that one of the t values is 1 when rearranged, or t minus 2 equals 0, which means that a second value of t is 2. So you've got two values of t in this case. Okay? So that is step number 2. Now in step number 3, remember, we need to put the two t values into our substitution, t equals cot. Okay, so let's try and calculate these x values. So in this case, when t equals 1, so remember our substitution is t equals cot, so if I put 1 for t into this equation, I'm going to end up with cot x equals 1. Okay, now in the video explaining the trigonometric ratios, okay, we can change the cot because unfortunately we don't have a cot button in our calculators. Okay, we only have sine, cos and tan, so we need to change that cot. So remember, one of the relations is cot is 1 over tan. Okay, so I'll just put it in a corner. Remember, cot x is 1 over tan x, or the reciprocal of tan is cot. So by doing that replacement, 1 over tan is equal to 1. That implies tan x is 1. So that is one of the equations that we need to solve. Okay? Now, how do we solve this equation? We're going to use our cast diagram. So tan x is plus 1. So our tan is positive. So to work out x, we're going to calculate the inverse tan of 1. And the inverse tan of 1 is a standard result. So it's a standard result. You should get 45 degrees. So that is your principal value. Okay. Now, since tan is positive, let's draw a quick cast diagram. Okay, so let's take a ruler. And let's mark the quadrants. So A, S, T and C. And we need to plot 45 where tan is positive. So tan is positive in the first and third quadrants. So measure your angles from the horizontal, remember. Yeah, so when plotting the angles. So in the first quadrant, here's 45 degrees. In the third quadrant, here's 45 degrees. And bearing in mind, everyone, bearing in mind the range in this question, so 0 to 360 is our range. So let's work out the solutions. So let me just insert them here. So therefore, the solutions are, so first one I'll call x1. So if I take a red pen just to make it clear, always start from your initial line. We need positive angles, so go anti-clockwise until you hit the first line. So that being 45 degrees. Okay, and the second solution, x2, start from the initial line until you reach the second line. So that is 180 plus 45, that is 225 degrees. Okay, right, however, these are the solutions for when t equals 1. We have another t value, t equals 2. So let's have a look. So, brand new page. So when t equals 2, so if I replace that in our substitution, t equals cot x, we're going to have cot x equals 2. But remember, going back, bearing in mind cot is 1 over tan. So let's replace the cot with 1 over tan x, that's equal to 2, which implies tan x is half. So this is the second equation that we need to solve. So I have a plus half on the right hand side, So I'll make a note that tan is positive. And let's work out the principal value. So inverse tan of half, that should be 26.6 degrees. That is your principal value. Okay. Now, in this equation, we need to plot 26.6 where tan is positive. So bear in mind that. So cast diagram time. So here is our cast diagram. Let's take a ruler. Let's include quadrants. Let's label the quadrants A, S, T, C. And tan is positive in quadrant 1 and in quadrant 3. And once again, we measure angles from the horizontal. So in the first quadrant, this is roughly 26.6 in quadrant 1. And in quadrant 3, from the horizontal again, this is roughly 26.6 in quadrant 3. So with this diagram, let's work out the solutions. So therefore, now remember, all of these solutions are solutions to one equation. So I call the last solution x2 for the previous equation, cot x equals 1. So I'm going to continue and call the next one x3. So the next solution x3, according to this diagram, from the initial line until hit that first line, so that being 26.6 degrees. And the last one from this initial line right round until you hit that second line, so that being 180, the angle in the straight line, plus 26.6. So that being 206.6 degrees. Okay, so in total we've got 4 solutions to this equation, and those are the steps. So those are the steps in order to solve equations of this type. But just to remember, whenever you have a power 2 in your trigonometric equations, chances are you're going to be using one of the Pythagorean identity. Okay, so this often works, so 9 times out of 10 this works, and it's a useful tip to know. Okay, so that ends the video. I hope you enjoyed this video.